Hi guys, this is Mr. Rego, and today we're factoring. So here's the list of the methods that we're going to be using today. Our first one is the greatest common factor. I'll put on the right side any number of terms. Next one is grouping, 4 terms. Trinomials, 3 terms. Difference of squares, 2 terms. Sum and difference of cubes. And all of this, we need to factor completely. We got to make sure that we always finish factoring. Okay? The number of terms, why am I putting that? Is because people says, how do I know which of these methods to use? You count how many terms you have. If you have 4 terms, then you use grouping. You got 3 is a trinomial, right? But you always start with greatest common factor. So let's start with the greatest common factor. We have, the question is going to be factor. They're not going to tell you, oh, factor using GCF, greatest common factor. They won't. They will say factor or factor completely. How do we do this thing? We have 18x cubed plus 27x squared. I said we always try first my greatest common factor. What is the process? I want to find the greatest common factor between my terms, my coefficients. So I got to break the 18 into factors. I know that 18 times 1 is 18. 9 times 2 is 18. 6 times 3 is 18. Those are all the factors of 18. I got to do the same thing for 27. 27 times 1. 9 times 3. And that's it, right? I think that's it. But we're looking for the greatest. I see that the 1 is a common factor, right? So 1 is a common factor. Is it my greatest? No. I see that the 3 is also a common factor. Is that the greatest? No. Why? Because the 9 is also a common factor. After that, the 27 or the 18, they're not common. Common means you have it in both terms. So my greatest is 9. So that's how I start, 9. Between the variables, if the variable is common, meaning it's here and is there, right? I have 2 terms. This is my first term and the second term. They're separated by a plus. Every single term will always be separated by a plus or by minus. I got 2 terms. X is here, X is there. Here's x cubed, here's x squared. I always use x with the lowest exponent. Between the 3 and the 2 is the 2. And this is my GCF. What's my next step? I open parentheses. And now I divide each term. I'm going to do that on the side. X cubed divided by my greatest common factor, my GCF. For this, you need to know how to work with the exponents. So please check in the description for my video on exponents. 18 divided by 2. 18 divided by 9 is 2. You see, my brain is going too fast. X cubed divided by x squared. Subtract the exponents, x to the first. So 18x cubed divided by 9x squared is 2x. That answer goes inside the parentheses. Next, second term, 27x squared divided by my GCF, 9x squared. X squared on the top and the bottom cancels. 27 divided by 9 is 3 plus 3. And I'm done. So this is my answer. You always check the inside of the parentheses. I will show you more of that in a minute. Alright, that's how we start with greatest common factor. Example number 2. 6x to the 4th power minus 18x cubed plus 12. Alright, I gotta factor this. The question is always factor, right? Because the whole lesson is about factoring. So let's get rid. I'm gonna follow the same process here. Alright, this is huge, understanding that process. 6, factors of 6, 6 times 1 or 3 times 2. Factors means 2 numbers that you multiply, you get that number. 18, 18 and 1, 6 times 3, 9 times 2. 12, 12 times 1, 6 times 2, 4 times 3. I believe there's nothing else. Okay, now what? Alright, So now I need to find out which one out of all those is my greatest common factor. Look, I always gonna have the 1 in there. I'm always gonna have the 1. Okay. And what else? I see a 2 here. A 2 is a common factor. Yes, it's everywhere. Is that the greatest? No, I also see a 3. I see a 3 here. I see a 3. So far it's winning the 3. Hold on. 6. 6. 6. That's the winner. Greatest common factor. 6. Another tip, so you don't have to do all this. Look at the smallest number between the 6, the 18, and the 12. It's the 6. Check if the 6 is into the 18. Yeah, it's 3 times. Check if the 6 is into the 12. Yeah, it's 2 times. Because the 6 is into the other ones, then 6 will be your common factor. Alright? Greatest common factor. Next, are my variables common? Is here, by the way, I got 1 term, 2 terms, 3 terms. They're separated by minus or by a plus, right? 6x to the 4th is 1 term, 18x cubed is another term, and 12 is another term. So this is a trinomial, by the way. X is in the first one, X is in the second one, but it's not here. So it's not a common factor. It's not common. Therefore, I have to open a parenthesis. Now I'm going to divide each one of them by 6. So let's do it on the side. 6x to the 4th divided by 6. 6 and 6 cancels. I have x to the 4th power, and that goes inside my parenthesis. Negative 18x cubed divided by my common factor. Negative 18 divided by 6 is negative 3 x cubed. That goes inside my parenthesis. 12 divided by 6, 2. And this is my final answer. Alright? That's the whole idea about greatest common factor. Next, according to the list, is grouping. Here we go. Now, as the list says, from grouping I got 4 terms. So let me write the first problem. So I got x cubed minus 2x squared plus 5x minus 10. Okay, I got 4 terms. When I'm doing grouping, what I need to do is, again, as the name says, I'm making groups. I take the first 2 terms and the last 2 terms. Look, that plus sign has to be on the second parenthesis. And what I do now is I do greatest common factor on each parenthesis. That's why we learned greatest common factor in the beginning. In my first parenthesis, common factor, the x is common. I take the x with the lowest exponent, which is the 2. And that's my common factor. What goes inside? X cubed divided by x squared is x. Remember, you need to know exponents to do all this factoring. So check the video, please, about exponents. Next, negative 2x squared. My second term divided by x squared. X squared from the top, cancels from the bottom. What's left? Negative 2. Negative 2. And that's GCF from the first parenthesis. Same thing in the second parenthesis. Common factor. Is the 5 into the 10? Yes. So my 5 is my common factor. Is the x common? No, it's here, but it's not in the second one, so it's not common. Therefore, I open my parenthesis. 5x divided by 5. 5x divided by 5, right? My first term divided by GCF. 5's cancel. My answer is x. Negative 10 divided by 5 equals to negative 2. That goes inside. Now, in grouping, how do I know if I'm on the right track, if I'm doing this right? The way you know is if your parentheses are the same. If your parentheses are the same, technically, what you're doing is you're taking a common factor of the parentheses. You open your second parenthesis, and whatever is on the outside goes to your second parenthesis. And this is my final answer. Grouping. Let's do one more. Let's say that I have x cubed. X cubed plus 6x squared minus 2x minus 12. All right. 1, 2, 3, 4 terms. Therefore, I have to do grouping. That's how you know what you're using, right? They're not going to tell you factor by grouping. First and second, third and fourth. You want to have that negative inside the second parenthesis. Be aware of that. GCF. What's in common? The x, right? I take the x with the lowest exponent. Within the cube and the 2, I bring the 2. Open parenthesis. X cubed divided by x squared, as we did here, x. We subtract the exponents. 6x squared divided by x squared, the x squared is going to cancel out. 6x squared divided by x squared, the x squared is going to cancel out. My answer is 6. Next, GCF here. Now, let's look at here. The previous problem I said, in order for you to know that you're doing it right, the parentheses have to be the same. I have right now my first parenthesis x plus 6. I'm looking to do the GCF here. I notice that both terms are negative, but my final answer here, my second parenthesis, have to be positive. Therefore, I know that I have to take a negative as a common factor. So I turn that into a positive number or variable. Now, let's look at the numbers. Is 2 into the 12? Yes, therefore that's your common factor. Is the x common? Nope. That's it. Open parenthesis. Next, negative 2x divided by negative 2. Negative 2 cancels out. The answer is x. Negative 12 divided by negative 2, positive 6. And we ended up having the same parentheses. Technically, this is one term. The x squared times this parenthesis. Technically, after that minus is the second term. I'm saying technically, right? What's in common between this whole first term and that second term? The parentheses. That's why I bring my parentheses first, and then I open my second parenthesis. What goes in the second parenthesis? This divided by this. The parentheses cancel. I have x squared left. Minus all this divided by x squared. X squared cancels. I have left the 2. So that's why I said, bring your common parentheses into one, and then whatever's on the outside goes to your second parenthesis. And we are done. Right? Let's work on another one a little bit more complicated. Now we have this little monster. Okay, so again, how many terms I have? Look at the signs, right? Look at the signs. I got 1, 2, 3, 4. Grouping. Here we go. Now, normally I take the first 2 and the last 2. But if there's anything in common, if I do that, is there anything in common between these two? No, not really. So for that effect, hold on. Hold on. I see that here I have an 8 and an 8. That's something in common. The last one has a 9b squared and the first one has a 9b squared. Okay? So why not organizing this thing? I'm not erasing anything. I'm just organizing. So what I'm going to do is I'm going to bring that 9b squared x, and let's bring that plus 9b squared y. And now these two minus 8y minus 8x. I'm just reordering. You are able to do this. Once I organize that to look, it looks a little better. Now I can do grouping. Again, I'm not erasing anything. I'm just reordering. So I'm reordering the whole thing. That's fine. I can see that I have a 9 as a common factor. I see that I have a b squared and a b squared, so the same thing, that's your common factor. The x is not common, the y is not common, so I open my parentheses. 9b squared x, my first term divided by 9b squared. 9 cancel, b squared cancels, x goes inside, plus 9b squared y divided by 9b squared. 9b cancels, 9b squared cancels. What's left? The y. And I'm done. GCF on the next one. I see that I have a negative as a common factor, and I see that I have an 8 as a common factor. The y is not common, the x is not common. I open parentheses. I divide. Negative 8y divided by negative 8. Negative negative is positive, so I have positive y. Negative 8x divided by negative 8. Negative 8 divided by negative 8 is positive x. I said the two parentheses have to be the same. X plus 6, x plus 6. They have to be the same. X minus 2, x minus 2. Are they the same? Kind of. I have x plus y, y plus x. But again, if I change the order, if it's like having 2 plus 3 or 3 plus 2, it's the same thing. 5, 5. I just need to organize them. I could have done it here in the beginning. I could have just flipped those two. Right? The order. So what I'm going to do is I'm going to reorganize it. X plus y, and that, instead of y plus x, I'm going to have x plus y. I'm not taking another parenthesis. I'm not doing anything illegal. I'm just organizing. So let's write our final answer. Common parenthesis, x plus y. Whatever's on the outside goes to your second parenthesis. And we should be done. This will be my final answer. Just a comment right now, because we're getting ahead into the video. We always check inside the parentheses. Again, according to our list, we have many different ways how to factor. So we want to check that always. Right now I have a difference because it's a minus, and 9 is a perfect square, b is a perfect square, but the 8 is not a perfect square. So therefore I'm not able to do a difference of squares on this. And I will talk about difference of squares in a minute. Okay? Alright, this was not an easy one for grouping. Let's get into trinomials. So we have two types of trinomials. Okay, x squared plus bx plus c. If there's no number in front of the x squared, then you have a 1, right? But when we have an a squared plus b squared plus c, then there's an a in the front. A, b, and c are any numbers. Okay, any numbers. But when we have an a, that means we're going to have a 2, a 3, a 4, something different of 1. So we're going to start with the first part, right? When there's no number in the front, and technically you have a 1. How do we factor these trinomials? I use something that is called product and sum. Product and sum. What's my product? The number at the end. What's my sum? The middle value. What I'm looking for is two numbers that when I multiply, I get 15. I'm going to do the same thing that we did before. 15 times 1, 5 times 3. Okay? Now, 15 times 1 is 15. 5 times 3 is 15. But again, any of those two numbers, when I bring it here, both are positive, so 15 plus 1 is going to give me 16. What am I looking for? 8. So those two numbers do not work. What about this 5 and 3? Both are positive, therefore it's 5 plus 3, which is 8. And that's what I'm looking for, right? Therefore my numbers are 5 and 3. And this is the whole work about this type of trinomials. Once I have my numbers, what's happening is that this x squared is going to break into parentheses. And then I bring my two numbers. This is a 5, which is a plus 5. And this is a 3, which is a positive 3. And I am done. This would be my answer. If you notice, for the most part, I get two factors, two parentheses, right? You see, as my answer, two factors. Just making a point right here, all right? For the most part. All right, let's do another one. Here we go. Now I have this. So I have x squared minus 4x minus 45. Same idea. I'm going to break this number because this is my product. I'm going to put a p as my product, and the sum is for an s. Two numbers you multiply, get negative 45. So it's going to give me negative 45 times 1 Negative 15 times 3, what is negative 9 times 5. As you notice, I put one of them negative. Why? Because a negative times a positive is going to give me a negative number. Negative 15 times 3 is negative 45. So any of those give me negative 45. But now I'm going to check which of this pair, the plus 1, right? Which of those pairs, this is going to be negative 44. And I'm looking for a negative 4. It's going to give me my answer. Let me bring this one. Negative 15 plus 3. And that's going to give me a negative 12. Negative 9 plus 5. And that's going to give me a negative 4. Oh, that's what I'm looking for, a negative 4. Therefore, my two numbers are negative 9 and 5. Obviously, this 5, if there's no sign, you have a plus 5, right? Again, same as before. The x squared breaks into x and x. This first number comes here, and the second one comes here. Doesn't matter which one you put first. I could put the 5 first and then the negative 9 second. It doesn't matter as long as you have two factors. And this is your answer. Now, I'm going to ask you something. Whenever we factor in, if you're not sure about your answer, multiply back. If I multiply back, I'll get the same original problem. X times x is x squared. X times 5 is 5x. And what I'm doing right now is called FOIL. Negative 9 times 5 is negative 9x. Negative 9 times 5 is negative 45. Normally, the middle two terms are like terms. 5 minus 9 is negative 4x. I bring down the x squared. I bring down the negative 45. And as you can see, I have the original problem. Okay? So keep that in mind. Your answer is this. But if you want to double check, multiply back and you should get the original problem. Let's do one more. Same idea. Trinomial 1, 2, 3. No number in the beginning, so you have a 1, right? You don't need to put a 1, but we know that. So let's do product and sum. The main idea is that you need to identify what are we doing? How can we factor this? 1, 2, 3 terms, trinomial. No numbers, so you factor this way. Break the number, 63. 1, I guess it's 21 and 3, and I guess it's 9 times 7. And anything else that I'm missing? I don't know. Okay, what about here? I gotta bring those two numbers and check. If they're positive, then 63 plus 1 is 64. And what am I looking for? I'm looking for a negative 16, so we're kind of far away. Next one, 21 and 3, and that gives me negative, I'm sorry, not negative, positive 24. 9 and 7, 16. So as you can see, all of these are positive, therefore my answers are positive. I notice that I have a negative 16, and I just found a 16. So that means those two numbers can work. So we got to think about it. In order for me to get a positive number, when I multiply two numbers, either both numbers have to be positive, or both have to be negative. Why? Because negative 9 times negative 7, negative gives me a positive. And that's how, if I turn these two into negatives, then it's going to give me a negative 16. And now I have my two numbers, negative 9 and negative 7. X squared, x, and x. My two numbers, one here, and the other one there. And I'm done. This should be the easy part, how to factor these trinomials. Alright, I showed you the three types, two positives, two negatives, and one negative, one positive. So those are kind of the ways that you have to factor any of those trinomials. Let's go with the second type of trinomials. Alright, here we go. Now we have trinomials with a leading coefficient different of 1. 8x squared plus bx plus c. Again, a and b and c are any numbers. Example, 3x squared minus x minus 2. Again, no, here we go. So when we're factoring this type of trinomials, I want to mix what we had before. This type of trinomials with grouping, okay? So let's mix those two processes. Here we go. The first and the last are going to be my product. 3 times negative 2 is -6. My sum is always the middle value. If there's no number here, you're supposed to have a -1. So my sum is -1. What are my numbers? So we always break the product, right? -6 is -6 times 1, -3 times 2, and that's it. Let's check those values. -6 plus 1 is -5. Nope. -3 plus 2 is -1. Now, the reason I put the bigger number negative is because my sum is negative. If my sum was a positive number, then I would have put the other way. Okay? I would put my bigger number positive. So I just noticed that if I did -3 plus 2, I got -1, right? Which is what I'm looking for. Therefore, my numbers are this. What's the process? So this is the first step, product and sum. Now what I need to do is I need to get into grouping. How do I get into grouping? In order for me to get to grouping, I gotta get 4 terms. So I'm gonna bring my original problem, and I'm gonna use these 2 numbers to break the middle value. Okay? So I'm gonna have, instead of -x, I'm gonna have -3x plus 2x. -3x plus 2x is -x, right? It's -1x. So I'm just rewriting. I'm not changing anything. I'm changing how it looks. I broke the middle value into 2 terms. I bring my first term and I bring my last term. And now I have 4 terms, which is grouping. And now we know grouping because we just did it. Here we go. Let's get some red. There we go. First 2, last 2. GCF. 3 is a common factor. The x is common. I just bring the x with the lowest exponent. 3x squared divided by 3x, x to the first, minus 3x divided by 3x. They cancel out, therefore I get a 1. Second parenthesis, I see that the 2 is a common factor. The 2 is here, so I bring a 2 out. The x is not common, therefore I open my parenthesis. There's nothing else that is in common. Now let me divide. 2x divided by 2, x. -2 divided by +2. Look at this. Parentheses are the same, so we're doing it right. Therefore, I bring my parentheses down, and whatever's on the outside goes to my second parenthesis. And that was the reason, so this is my final answer. That was the reason I did grouping before, so we knew what to do here. All right, let's try to work those 3 problems in here. Second one. Now we have to factor this trinomial. It has a leading coefficient, therefore I gotta multiply the first times the last. So my product is 9 times 2, which is 18. My sum is -9. Let's break those. 18 and 1. 9 times 2. 6 times 3. Okay. I don't think there's anything else. -9. Well, now we check these values in here. Again, my product, 18 times 1, both are positive. So if I bring them over here, it's going to give me a positive number. And the number that I'm looking for is a negative. Same as the previous one, that we did already in the trinomials. I can have either 2 positives to get a positive, or if I multiply 2 negatives. Remember that this P stands for product, so I'm multiplying these 2 numbers. Right? I'm multiplying those. -6 times -3 is +18. -9 times -2 is +18. Now they're negative. So if they're negative, then it's going to give me a -19. All right, at least I have the sign. Let's keep going. -9 minus 2. -11. Nope. -6 minus 3. Oh yes, -9. And I got my number. What are my 2 values? -6 and -3. Here we go. What do? We rewrite the original problem. 9x squared minus 9x plus 2. I don't change the original. There's a lot of mistakes. People change the 2. People change the 9. No, I do not. I just break the middle value into negative 6x minus 3x. Because if I combine those, I get negative 9. So I'm not changing the values, I just break the middle value. Bring the first one, the same thing. Bring the last one, the same thing. And now I got 4 terms, which is grouping. So what we're doing right now is, guys, we're getting like experts doing a grouping, right? That's what's going to happen. First 2, last 2. Between the 9 and the 6, a 3 is a common factor. X squared and x. Divide. If you have to divide on the side, go ahead. 9x squared divided by 3x. 9 divided by 9 is, 9 divided by 3 is 3. X squared divided by x. Minus 6x divided by 3x. X cancels. 6 divided by 3 is 2. So, look at the second parenthesis. It looks like almost what I have here in the bottom. But if you notice, the signs are different. That means I have to take a negative 1 as a common factor to change those signs. Let's try it out. Negative 3 divided by negative 1. Positive 3x. 2 divided by negative 1. Negative 2. And now my parentheses are the same. Therefore, they come into 1. And whatever's on the outside goes to your second parenthesis. A lot of practice on factoring, on grouping. Alright, here we go. We got plenty of space for our last problem on this type of trinomials. Let's write it down. And here we go with this little monster, I guess. So, the reason I'm bringing this is because a lot of people get confused with this. Very common mistakes. People say, oh, hold on. Why do I have a y? What's going on? Is this different? Nope. I have a trinomial, 1, 2, 3. I have a number in the front, so the process is the same. The only difference is that instead of having only one variable, I have 2 variables now. But again, the process is the same. Let me show you. 6 times negative 6. Negative 36. My sum. Negative 5. Break the 36. 36 and 1. Negative 18 and 2. Right? To get a negative, I need one negative. Negative 9 and, oh, hold on. Negative 9 and 4, right? I'm sorry, I was going to put 2. Anything else? 12 and 3, right? Let's see. Let's bring them over here. Negative 36 and 1 is going to give me negative 35. Okay, which is no. I'm looking for negative 5. Negative 18 and 2 is going to give me negative 16. Nope. Negative 9 and 4 is going to give me, negative 5. I don't need to check the last one. I got my negative 5. Amazing. So my numbers are negative 9 and 4. What am I doing with those? Breaking the middle value. Don't forget, you're not changing anything. You're just breaking the middle value. So I'll bring the same thing. What happens now is that my middle value has 2 letters. Does not matter. So instead of negative 5xy, I write, what are my numbers? Negative 9xy, and the 4 is positive, plus 4xy. That's it. Break the middle one. Bring everything else the same. And keep going with the process. So here's where people can make a mistake. No, make sure you put the 2 variables, xy, xy. I have 5 mangoes, 5 papayas, whatever. I bring it to negative 9 papayas plus 4 papayas. There we go. Let's go with papayas. By the way, if you're still with me, make sure you subscribe. You haven't subscribed to the channel, all right? We need 1,000 subscribers as soon as possible. Here we go. Let's keep going. 1, 2, 3, 4 terms. What do? Grouping. Again, we're going to have a master's in grouping. First 2, last 2. GCF between the 6 and the 9. That's right, 3. X squared and x. X. Is the y common? It's here, but it's not here, so it's not common. Open parenthesis. 6x squared divided by 3x. 6 divided by 3 is 2. X squared divided by x. x to the first power. Negative 9 divided by 3, negative 3. X divided by x cancels. I have the y left, I bring the y left. If you need to write on the side, guys, write on the side, negative 9xy, right? This divided by 3x. Negative 9 divided by 3 gives you negative 3, right? X and x cancel, and you have y left on the top. And that's what I have here. Next, you see it between the 4 and the 6? 2. Is the x common? Nope. Is the y? Yes. You bring the y with the lowest exponent. And now I divide 4xy divided by 2y. 4 divided by 2 is 2. X, there's no x here, so it stays. And y divided by y cancels. Minus 6, negative 6 divided by 2. Negative 3. Y squared divided by y. Y. Are my parentheses the same? Yes, so I'm doing it right. I'm not changing the process because it's something else. Whatever is on the outside, let me put that up with a different color because that's huge. Whatever is on the outside comes to your second parenthesis, 3x plus 2y. And this is your final answer. Again, you always want to see if there's anything else you can factor. For the meantime, all these problems, there's nothing you can do inside those parentheses. Next, difference of squares. Let's go. So according to our list, our next method is difference of two squares. That's how we call it, difference of squares. Technically, it's difference of two perfect squares. Difference of two perfect squares. Difference, there's a minus around. Two perfect squares, there's only two terms, as the list says. X squared minus y squared. That's it. That's my problem. How do I factor this out? Okay, so I'm going to have, first of all, a minus in between, and I got two squares, right? A variable to the second power, or 36, or 49, or 16, a number that is a perfect square. As you can see in all my problems, guys, you're going to have, for the most part, two factors. For the most part, right? So that means this is going to give me two factors. What do I do to get those two factors? You take the first term and you do square root of that. If you don't know how to do this, please check my video, Radicals, okay? I'll explain the whole thing. I'll make a link underneath. Square root of x squared is x. I take the second one, not with the minus, just the y squared. And I do the same. Square root of y squared is y. So now I have my x and my y. The first answer, x squared, square root is x, that goes in the beginning of the parentheses. Plus or minus, this is where the trick is for the difference of squares. And then my second one is the y squared. Square root is y, and I close. And that's my answer. Let's factor x squared minus 4. Alright? Like I said, you can either have a variable to the second power or a perfect square. Or in that, basically any variable with an even exponent. And I'll explain that in a minute. Let's do this one. I gotta factor this. I have a minus, 4 is a perfect square, x is a perfect square, so this is a difference of two squares. Factor. I gotta do the square root of the first one, which is x, square root of the second one, without the negative. Don't put the negative in here because then it's gonna be an imaginary number. Square root just the number, and that's 2. My answer, 2 parentheses. The first term is x squared, therefore the square root is x. That goes in the beginning, x and x. Plus, minus. Square root of 4 is 2. 2 and 2. And that's my answer. So as you can see, the process is not difficult. The idea is to identify that this is difference of squares. So I have x to the 4th power minus 16. I have a minus, and I got two terms. So it could be a difference of two squares. 16 a perfect square? Yes. X to the 4th a perfect square? Yes. Any variable with an even exponent is a perfect square. Let's solve it. So now we have to do square root of both. Square root of x to the 4th and square root of 16. Remember, just the number, not the sign. X to the fourth, square root of x to the second. Basically, you divide the exponent by 2. Alright? Again, go to the radicals video and I'll explain better. Square root of 16, 4. My answers, 2 parentheses, because x to the fourth is my first term, then x squared goes here and there, plus and minus, or minus and plus, doesn't matter as long as they're different signs. And 16, square root of 16 is 4, that goes at the end. 4 and 4, and that's it. All done. Am I done? You always check the parentheses. Okay? I see a parenthesis, I got 2 terms with a plus. This is a perfect square, that's a perfect square. But in my list, there's no sum of squares. But there's a difference of squares, right? X squared minus 4, we just did, look right here. It's a difference of squares. Because I checked in the parentheses, that means I have to keep factoring this parenthesis. So this one, there's nothing that I can do. I just bring it down, x squared plus 4. And now x squared minus 4, we factor. X squared goes into x and x, plus and minus, the square root of 4 is 2 and 2. The same thing that we just did. And this is my final answer. I said before, for the most part, I'm going to have 2 factors, 2 parentheses. But sometimes you have to keep factoring, which is what happened in this case. That's your final answer. Let's do something a little more bigger. And the idea is to, expose you to difficult problems as well. Let me factor this. Let's say that I have 36 x squared minus 49 y squared. Alright, now there's more stuff. First, we need to identify if there's a difference of squares or not. Minus in between, and I got 2 terms. 36 is a perfect square. X squared, okay, so those are perfect squares. What about the other side? 49 is a perfect square, right? Square root is 7. And y is the second power, so that's a difference of 2 perfect squares. What do? Same process. Square root of the first one. But the first one is all this, 36 x squared. The square root of 36 is 6. The square root of x squared is x. So that's what's going to happen on my first parenthesis. 6x, 6x, plus, minus. What's next? My second term. 49y squared. And what do? Square root of that. Square root of 49, 7. Square root of y squared is y. 7y here, 7y there. I always check the one with the minus for the most part to see if there's a difference of squares. It's not a difference of squares. That's my answer. Okay, so this is a common problem that a lot of people have trouble with. And that's what I bring because it has 2 terms. Not 2 terms. It has a variable and a constant. So people get confused. Alright. What's next? Sum and difference of cubes is our last thing. So we're in the stretch, guys. Alright. It's strong. Alright. We're reviewing the whole thing. Right now we're reviewing the whole factoring. Excellent. So now we have sum and difference of cubes. I wrote the first one. A cubed plus b cubed. This is the way you factor. It's a pattern. Nothing that we can do. Let me explain by doing the second one. How does this pattern goes? Alright. How does it work? If you notice, I have 2 parentheses. The first one here. And obviously the second one, which is bigger. The idea is to get the first parenthesis. I went from a cubed plus b cubed to a plus b. What happened? What I did was, I took cube root of that. Cube root of a cubed is a. Same as the difference of squares. Cube root of b cubed is b. So, for my first parenthesis is the cube root of this and the cube root of that. With the same sign. That's my first parenthesis. My second parenthesis. My second parenthesis depends on the first parenthesis. Why? Because it's this to the second power. a, whatever you have as your first term, to the second power. You change the sign. If it's positive, it goes negative. If it's negative, goes positive. The middle term is a and b, which is basically the first term times the second term. A times b is ab. Again, you ignore the negative. Right? You ignore the negative, just whatever the second term is. My last term is the second to the second power. The second is b to the second power. And we're done. It's always the same. Unfortunately, we have to memorize this pattern. There's nothing much that we can do. Let me give you an example. Let's get black. So let's say that I have x cubed minus 64. And the question, again, all this is factor. Factor this. First of all, we need to identify how can I factor this. I see a minus, and I got two terms. So the only two choices is either a difference of squares or a difference of cubes. Because I see a 3, then this could be a difference of cubes. Is 64 perfect cube? So for that, first of all, let's do cube root of x cubed, which is x. Then I do cube root of 64, not the sign. If you put that in your calculator, you get 4. So now what I do is, let me bring the pattern. Okay, so I know already that it's going to be two parentheses. My first parenthesis is the cube roots. So cube root of x cubed is x. I bring the same sign. And cube root of 64, not with the sign, only the 64 is 4. Cube root of that is this, minus cube root of 64 is 4. Second parenthesis depends on the first one. That to the second power. Change the sign. First times the second, x times 4. You don't write x4, you write 4x. And the square of the second one, which is 16. And I need no space for that one. Alright? That's the idea. Let's do one really difficult. Here we go. This is like a map. Alright, let's factor 8x cubed plus 27. If you notice now I have a number, coefficient with an x. Factor. How do I know what to use? I see a plus, so I say sum. Because I see a 3 as an exponent, this is a cube, so it could be a sum of cubes. I gotta find out. I gotta bring the 8x cubed and see if I can take a cube root of that. Cube root of 8 is 2. Cube root of x cubed, remember you divide this exponent by the index, so 3 divided by 3 is 1. So cube root of this is 2x. Here we go. That's my first parenthesis. 2x plus cube root of 27 is 3. And now I have my first parenthesis. Let's get the second one. The second one, here comes the trick. It's the first one to the second power. But the first one is 2x to the second power. You got to raise to the second both. 2 to the second is 4. X to the second is x squared. A common mistake is people don't square the 2. That's the reason I'm doing this problem. What's next? Change the sign. Minus. The first times the second. So 2x times 3. That gives you 6x. Last term. That to the second power. 3 squared is 9. And I am done. Alright, and that's sum and difference of cubes. Now what I'm going to do is, I'm going to do a couple of problems factor completely. We're done with all the methods. Okay? I just want to make sure that you're aware that sometimes they give you problems and they don't ask you to factor completely. And people stop halfway. And because you stop halfway, then you don't get full credit for the problem if they give you some credit. Okay? Depends. Question. Factor. 20y to the 4th power minus 45y squared. What do? I have no idea. I see a minus. I see something to the 4th power, so that's a square. This is a square, but 20 is not a perfect square. So remember, I always said, check if you have greatest common factor. Alright, greatest common factor. I see that the 20 is 5 times 4. I see that 45 is 5 times 9. So 5 is my common factor. Y to the second, y to the fourth. Y squared is a common factor. And now you open parentheses. Again, not simple. Try to, stop the video and try to solve it. Now, first term divided by my GCF. 20 divided by 5 is 4. Y to the fourth divided by y squared. You subtract the exponents, you get y squared. Minus 45 divided by 5 is 9. Y squared divided by y squared, they cancel out. Done. Some people will stop here. No. Check the inside the parentheses. Do I have anything else inside the parentheses? Minus 4 is the perfect square. Squared, squared. That's the difference of squares. Meaning, I bring the outside, and this is the difference of squares. How do you factor the difference of squares? Square root of this. Square root of 4 is 2. Square root of y squared is y. So it's 2y here and 2y there. Difference of squares, plus and minus. You got to remember all those patterns. Square root of 9, 3 and 3. Still, we want to check. We always check the one that has a minus, just in case. Is that a perfect square? So this is my answer, the whole thing, including the 5y squared. Last but not least, let's say that I have, this is a nice one, because I see people going crazy with this. 6x squared minus 6x minus 12. I know it's a long video, but I need you to look at it. So most people will say, oh my God, really? I gotta multiply this times the 12. It gives me negative 72 and the whole thing. No, you don't have to do that if you check greatest common factor. 6, 6, and the 12, 6 into the 12. So 6 is a common factor. Is my x common? Nope, it's not here. So I open my parentheses. 6x squared divided by 6. X squared. Negative 6x divided by 6. Negative 6x divided by 6. Right? 6 and 6. That's going to give me negative x, or negative 1x. Negative 12 divided by 6. Negative 2. Hopefully you don't stop there. You say, oh, hold on. Okay, so I have a parenthesis. I have a trinomial on the inside. Is there anything that I can do with the trinomial? Yes, there is, right? That's the answer. Remember, no number you have a 1. And this is going to be product and sum. Two numbers that you multiply, you get negative 2. But when you add, you get negative 1. That's right. The answer is negative 2 times 1. Why? Because negative 2 plus 1 gives me negative 1. So my numbers are negative 2 and positive 1. So whatever's on the outside, you have to bring it. The trinomial, two parentheses, x squared, my numbers. And now I'm done. So just to show you that you have to be careful with this thing. Okay? Again, guys, subscribe to the channel, like the video. I hope if you ended up with me here, that means you're learning and you're interested in learning this thing. So hit the notification bell so you get notified when we do more videos, which we will. Alright guys, take care and thank you for watching. Bye bye.